Please pause the video and try this question. All right. If mn is not equal to 0, if the product of these two variables is not equal to 0, when would that happen? That would only happen if neither of m and n is equal to 0. So m should not be equal to 0, and at the same time n should not be equal to 0. All right. If this product is not equal to 0 and 25% of n equals 37.5% of m. A certain percentage of n equals a certain percentage of m. All right. If this is the case, then what is the value of this expression here? 12 times n divided by m. All right. So let's see, can we convert this thing here into an equation? We do have a relation between n and m here. What's the relation? 25% of n equals 37.5% of m. So basically 25 divided by 100 times n equals 37.5 divided by 100 times m. I can anyway get rid of the 100 in the denominator on both sides. I'm left with 25 times n equals, let me convert the numerator 37.5 from a mixed fraction into an improper fraction. Basically I would get 75 divided by 2 times m. All right. Now this 25 here, I can divide both sides by 25, and then I'm left with 3 by 2 m on the right side. So n equals 3 by 2 m. What was the question? What is the value of 12n by m? So let me plug in this value of n into that expression. 12n by m, 12 times 3 by 2 m whole divided by m. All right, which is equal to 12 times 3 by 2 and then times m by m. So these m's will get cancelled. This 2 here will get cancelled with the 12. I'm left with 6 times 3, which is 18. The answer to this question is A. Now, this here was one approach to go about the question. Let's discuss another approach. So, what do we have? The product of these two terms is not equal to 0, and then 25% of n. A certain percentage of one variable equals a certain percentage of another variable. Let's just focus on this bit. Maybe 37.5 is difficult to comprehend initially. So to start off, let's just look at some easier percentage. What if I tell you 25% of x equals 50% of y? What can you understand about x and y from this piece of information? 25% of something is equal to 50% of something else. So which one would be bigger, x or y? 25% or a quarter of something is equal to a half of something else. Let's think of x and y as cakes, for example. 25% of one cake is equal to 50% of another cake. So what can we say about the two cakes? Which cake would be bigger? The first one or the second one? A quarter of one cake is equal to a half of the other cake. So overall, the first cake would be bigger. That's why a quarter of that cake is equal to a half of the other. In other words, in this case, x would be greater than y. Now, let's see if we can apply the same understanding to our original given piece of information. 25% of n is equal to 37.5% of m. Now, which one would be greater, n or m? Let's try and understand that. 25% of one cake is equal to 37.5% of the second cake. A bigger percentage of the second cake. So which cake is bigger? A smaller percentage of the first cake is equal to a larger percentage of the second cake. So overall, the first cake would be bigger. Only then would a smaller percentage of that still be equal to a larger percentage of the second cake. So just this much, focusing on what percentage of n is equal to what percentage of m, and just noticing that 37.5 is a bigger percentage helps me understand that n is greater than m. How does that help me? I need to figure out the specific value. Just by understanding what's greater, can I calculate the exact value? No, I can't calculate the exact value, but let me see if I get some rough estimate at least. Now, 12n over m, I can write as 12 times n by m. What I've done here is I've taken the n and m separately since I have at least some relationship between them established. I know that n is more than m, which tells me that in this expression here, within the brackets, the numerator is more than the denominator. So what does that tell me about the expression within the brackets? If the numerator is greater than the denominator, I can understand that the expression within the brackets would be more than 1. So the whole expression 12n upon m is basically 12 times something which is more than 1. So the overall result, what can I say about the overall result with regards to 12? The overall result will be more than 12. 12 times something more than 1 will be something more than 12. So what's the value of 12 times n by m? Well, it has to be more than 12 for sure. Do I have the exact value yet? No, but I at least have a rough estimate of what the value needs to be. Let me get into the answer choices to see if I can eliminate any. 9 by 8, that's 1 by 8, 1 point something, definitely less than 12, can't be the answer. 3 less than 12, gone. 8 less than 12, gone. B, 32 by 3. 36 by 3 would have been exactly 12. 32 by 3 would be 10 point something. 33 by 3 would have been 11. So this value here is less than 11. Therefore, definitely less than 12. Gone also. I've been able to get rid of 4 answer choices. I'm left with only 1. That must be the correct answer. So I could solve this question actually without any calculation, just by understanding that a smaller percent of n is equal to a larger percent of m, and that means that n would be more than m, which tells me that 12 times n by m would be more than 12. All this I could actually understand mentally itself, and I could solve this question with this reasoning in a very short span of time. Now, you might be wondering, what if the answer choices were different? Maybe we were lucky. Well, a couple of things. First, this is an official GMAT question. So our objective when we see a question on the screen, our foremost objective is to solve that particular question. At that point, we won't worry about what if the answer choices were different. Our objective at that point is to solve. And this certainly is one way to get to the answer for this question. While practicing, once you've answered, then of course we should think that what if the answer choices were different? Well, this whole thought process didn't take me a long time. And by using this thought process, at least I could have eliminated maybe, if not 4, maybe 2 or 3 answer choices. Even if, let's say, I couldn't eliminate any answer choices, even then I get an estimate of what the answer would need to look like. And as I become more and more comfortable with percentages, such thought process would actually start coming more and more naturally. And so overall, thinking along these lines would not have taken me a long time, ideally. And therefore, I strongly recommend that we apply this kind of understanding before we jump into solving, even if you realize that after eliminating a handful of answer choices, you still need to get into solving. It's still useful. For this particular official question, actually, it was immensely useful because I could get rid of 4 incorrect answer choices. I was left with only 1, so that one had to be correct.